Here we are in Chapter 10, Section 2, problem number 11. We'd like to point out that the problems across the different sections of Chapter 10 build on each other. So what we have here in Section 2, number 11, is the same base problem that we'll be looking at when we're in Section 4, problem number 11. And then later in when we get out to Section 7, problem number 11. So ensuring that we have this first step in the first section, Section 2, in place will be good because we're going to build on that across this area. So essentially, if I'm looking at problem number 11 across multiple sections, it's really just one problem in many different places. Okay, and builds on itself, so it's not so bad. Let's look at this one. The age X in months and vocabulary Y were measured for 6 children with the results shown in the table. Okay, so 13 months, just over a year. The kid knows 8 words. By the time they're 18 months, they know 30 words. Okay. Compute the linear correlation coefficient for these sampled data and interpret its meaning in the context of the problem. All right, so encourage you to print out a version somehow, how you would like to do that, of Section 9 of Chapter 10, because that's the equation set that gets used clear across the chapter. And we'll be starting off with some of the first things you see at the top of that equation list, and then working our way, adding more concepts as we go. So as I look here and I see what's going on, and I'm coming up with the linear correlation coefficient, I've got this R equals the sum of the squares of xy divided by the square root of the sum of the squares of the x's times the sum of the square of the y's. So I'm going to have to be calculating the sum of square of x, the sum of square of y, the sum of square of xy. And as I look at that set of numbers, Excel is going to be the tool to help me do this the way I look at things. So you can do this multiple ways. I'm going to jump over to Excel and let's look at what I did there. I worked that out in Excel first, and I'll kind of talk you through what I did. All right, so here we are, and we have that same set of data. I just went through and essentially just reproduced that set of values that were right out of the problem. And now, since we're looking for the linear correlation coefficient, I look to see what are the terms I needed there. And as I mentioned, I need the sum of squares. And if I look at the sum of square of x's and sum of square of y's, I need the values in terms of those definitions. So what I did then was looked at what are those things I'm going to need and created those. So sum of x, let's look at that first, because I'm going to need the sum of the x's. I need that for the sum of squares xy. So to do that one, what I have is just the sum of the x's. So here, if I look at this value, it says the sum of the x's is the sum of those values there. Similarly, for the y's, I have just the sum across the values I have there in the table. You could do this multiple ways. You could have them in rows, you could have them in columns. And it's going to continue to follow the example that was there in the way that was laid out from the data in the text example here in problem number 11. All right, so I need the sum of the x, sum of the y's. I also need the sum of the x squareds. So in this case, I'm using the sum of square function. And what that does is it takes each value across each of those cells, and so it'll take 13 and square 13. Then it'll add to that 14 squared, plus then 15 squared, plus 16 squared, plus another 16 squared, plus 18 squared, and then give that sum. So that's what it does for me right there. Similarly, y is the same kind of thing. I use that sum of square function as well for that same set. Sum of xy, what I did on this one was I did a sum product, which is an interesting function inside Excel. So it looks at these two different rows. It's going to take the array from C4 to H4, and then also the one from C5 to H5. So it's going to look at the column first here, and it'll take the C4 times the C5. Then, because it's doing the product, and it's going to sum the C6 times H6. Then it's going to sum C7 or E. I must have mentioned that wrong. Anyway, it's going to go column to column. So it's going to do the column D4, D5, then E4 times E5 plus F4 times F5, etc. So that gets us that cross product type thing, that x times y, and sums all those up. So you can do that several different ways. You could actually create another column out here that's the xy column And you could put in an equation here saying this equals the 13 times the 8, and then do that all the way across, and then come out here at the end, and you could insert a function. Oh, formula, I'm not inserting a function. Auto sum. Chunk. And I get 1761, which is the same as the 1761 down here. So a lot of different ways you can do that here in Excel. I'm just jumping around that one. All right, so let's go down further here. This next one in my list that I'm going to need is the sum of the x's squared. So do the sum of the x's squared. I had the sum of the x's up here. So what I did was, actually I did this a second time. I went through and I summed across that whole set of values, which I had done up above in this point. And then I used that caret function right there to take that value of sum and squared it. Similarly for the y, so I have the sum of the y's across there. So that row 5, I had those summed. And I've got the caret function, so that had, or caret 2 to square it, so that value is squared. So I did the sum first, then squared it, where up here I squared it, and then I summed it. And I put also here what are the number for n. I could have just set the number in there saying I've got 6, because I can count to 6. Or here I use the count function for the row to say how many values I have to come up with my 6. So that gives me all the pieces I need, those building blocks I'm going to be using for building this sum of the square root of x's, sum of the square root of y's, and sum of the square of xy. So I go back to the formula off of that, where I pulled it from the end of the chapter in chapter 9, which is the same one we just looked at just a bit ago up in the definition. And so for the sum of the square root of x's, it's the sum of the, let me go ahead and highlight it this way so it kind of shows it up. So we've got the, over here, the d12, which is d12. So that's the sum of the x squared. So this is this, it's squared first, then summed. Okay, that's what I've got there. Minus 1 over n, so here minus, so n is d17. I've got over n there, and that's the second piece. So d15 is the sum of the x squared, which was that d15. So I created that same formula for the sum of the x squared, or the sum of squares of the x's, using it in Excel of what's going on with that formula to get me the value I needed there. In this case, I turn out with that 15.333. And you know what? That's lots of significant digits. So we should be more around 4 for what it looks like we've got here in terms of our values. But that's approximate. So you see what I did for the talking you through the sum of the square root of x's. Similarly, for the sum of the square of the y's, I'm doing that same, looking at that same formula, not looking at the same formula, looking at the formula for sum of the square of y's, which is the same concept of the sum of the square of x's. And so I essentially created that same one that we had just seen. So I'm looking at the sum of the y squareds minus 1 over n, so d17 times the sum of the y squared. And that gives me that particular one. Now for the xy, I took a little bit more here because the step is I've got to do the sum of the x's times the sum of the y's. But I start off with the sum of the xy's. So let's see, that's the blue one up here. The blue one down here there's the sum of the xy, yep, minus then this whole set of the sum of the x's, that was the red one, times the sum of the y's, that was the purple one, and that's divided by n, which was the green one. Close that, subtract that from the other one, and that gets me the sum of the square of xy. Right, I've got all the building blocks done. Now then, our question here is, what's the linear correlation coefficient? That's what we were looking at for this particular problem. So I go to the definition that we had, which was the linear correlation coefficient R equals the sum of the square of xy. So that's the blue one, d21. And that's divided by the square root of the sum of the square of x times the sum of the square of y's. So inside the middle here of this formula, I've got the red times the red times the purple. That's the sum of the square of x's times the sum of the square of y's. Then I take the square root of that, And then that's what gets what D21, so the sum of squared x's gets divided by that beast, which gets me the answer I have here. And let me do away with several of those extra values out there. So my linear correlation coefficient for this particular problem set is R, which is 0.948. And I think the other point that was asked about here was, what does that, how do you interpret that? So essentially what this is saying is that each year, or sorry, not each year, each month, as X gains another month, then Y grows by, no, that's not what it's doing. That's the next section stuff. What it's doing here, the linear correlation coefficient, is how related are these two? So it's saying that, and since that's a 0.948, that's close to 1. 1's the max, so 1 means they're extremely correlated. So this is saying, yes, these are quite correlated. It's near 1. So the word usage, the number of words known, increases with the independent variable of the age, and they're highly correlated. So there was number 11.